Morning everyone. Myself Vivek. I am part of this prestigious unique foundation class result from last 4 years. I am here to present a seminar on the topic periodic classification of elements. So, first, the by the word classification, what do we understand? The word classification tells us that we are arranging certain things in a correct order of manner, such as we are going to classify a class in certain groups. Like we'll take an example. We'll classify the students on the basis of their marks obtained in exams. Like we'll make a group of students who got marks above 90, above 70, above 80, and so on. There was a need of classification for the elements too. Before 200 years, there were almost 30 to 50 elements known, but they were all list. There was not any classification and any order of their elements. Like for example, I am writing some elements: sodium, potassium, rubidium, cesium, francium. So these are the elements in a single group. Doesn't they look messy? They are looking messy. There is no connection between sodium and rubidium, cesium and francium, and also fluorine. This is an halogen, which means it has completed its octet rule, which means it has electronic configuration of 8 to 88. That means it is a noble gas and it's inert gas. So there was enough classification of elements too. So there was need of classification of elements. There was a need of classification of elements too. The tried to classify the elements was done by Daubigny in the year 1870. There were almost 30 elements known to him. 30 elements known to him, but they were all not arranged in a proper manner. So he thought to arrange them in a proper manner to study the various properties. As we are classifying the elements, to study it in a correct manner and in a shortest period of time. Studying these elements is quite a difficult task because they are not arranged in their proper manner according to their various characteristics. So Daubigny, there were almost 30 elements known to him. So he tried to classify the elements of 30 elements known. He arranged the 30 elements known in the increasing order of their atomic mass, and so he made certain traits. But what do you mean by traits? Traits are those in which three elements are present, in which the middlemost element is the arithmetic mean of other two elements, such as sodium, potassium, and rubidium. So this is not a trait, but we'll take an example. The atomic mass of rubidium and arithmetic mean of potassium is equal to the atomic mass of sodium and rubidium divided by 2. That is, so this is not an example. This is an example. It is not a trait. So Daubigny made certain traits, but this was first attempt to classify the elements. But there were some also demerits too. The demerits are he could make only three traits which satisfied his statements. So this was his first demerit. And the second attempt to classify the elements was done by Newlands. So one trait of Daubigny was lithium, sodium, and potassium. The atomic mass of lithium is 7 and potassium is 39. So this equals 46 divided by 2, that is 23, and this gives the atomic mass of sodium, that is 22. This one trait satisfied his statement. So he gave some certain statements that all 30 elements can be enclosed in traits, but there were only three traits, and there were no more than three traits could be made. The second attempt to classify the elements was done by Newlands in the year 1864. So what he stated first, that every eighth element of the 56 known elements, that means at this time 56 known elements were known. Thus every eighth element showed the properties of the first eighth element, such as if I am writing sodium here, and this is the eighth element, like we can say potassium. Okay. So what he stated, this element showed the same properties as sodium, and so he classified them in same group. But what he did, he also arranged the known 56 elements in the increasing order of their atomic mass. He octave, his name, that means law of octave. This satisfies this. So uh, the demerits of Newland's law of octaves, that is, only up to elements calcium, no more than up to element calcium satisfied this statement. That means after calcium, no other element satisfied his law of octaves. And also, so after calcium, none other elements satisfied his statement. And also, what was his second demand was, in order to fit the elements, 56 known elements, he wrote two elements in a single slot, such as calcium or rubidium in single slot. Also, the third demerit what Newland's law of octaves was that he thought that only 56 elements will be discovered, and in future no other elements will be discovered. And this was his third demerit. Like, I'll give an example about his in two slot he, like nickel and cobalt. So in order to fit the elements in his table, he put two elements in a single slot. Mendeleev's periodic table. Mendeleev's periodic table is one of the most successful attempt to classify the elements. He did it in the year 1869. There were almost 63 elements known to him at that time, and he predicted their chemical properties on the basis of their oxides and hydrides formula. He wrote the 63 known elements in the increasing order of their atomic mass, and after certain periodicity, some elements showed the same properties to each other, such as sodium, after some time lithium, potassium. So these three properties showed same property. These three elements showed same properties, and so he arranged these elements in a single row. This we called it group of elements. These three showed the same chemical properties. He predicted the chemical properties on the basis of oxide and hydride formula. When we react sodium with oxygen, it gives Na2O, while also comes with lithium. When we react potassium with oxygen, it gives K2O. But how Na2 and Na2O, Li2O or K2O comes is when we on the basis of the valence, sodium has valency 1 and its electronic configuration is 281, and electronic configuration of oxygen is 282, and the valency is 1 and his valency is 2. So valency of sodium is 1 and valency of oxygen is 2. When we cross it, we get Na2O. This means the valency, this process with Na, one process with oxygen. So by this way we get Na2. That means this shows that these three elements show the same properties. So this is first group. In the same way, he classified the elements in the same way, such as magnesium. The formula of it is R2. Oxide formula is R2. When we react these elements with hydrogen, that which gives sodium plus hydrogen, it gives NaH. Valency of sodium is also 1 and valency of hydrogen also 1. So in the same way, the hydride formula for this group is RH. The second group's oxide formula is RO, and the hydride formula is RH2. Similarly, when we react magnesium with hydrogen, we get we get magnesium hydride, and with oxygen Mg plus O, it gives MgO, because the valence of magnesium is 2 and the valence of oxygen is 2. In this way, he classified the elements in certain groups. The merits of Mendeleev's periodic table are he left some spaces, 3 spaces in his periodic table, which he predicted that there will be more elements discovered in the future. And when he made the periodic table in the year 1869, at that time the halogen, that means inert gases or noble gases, were not discovered. But when they were discovered, the certain other column can be made, and the halogens could be accommodated in his periodic table. The another merit was that it was a very arranged. It was in a very arranged format, and it could be made various. It was in a good manner, and there were some demerits, as there are advantages and disadvantages of certain things. The disadvantage of Mendeleev's periodic table was the position of hydrogen was not specified. Like hydrogen has valency 1, okay, and hydrogen has valence electrons 1. So it can be placed in first group also, and it can be placed in the group which has valency 1, and in the group which has valence electrons 1. So these are the demerits of Mendeleev's periodic table. So moving on to next point, that is modern periodic table. As we know, the modern periodic table could accommodate isotopes, but the limitation of Mendeleev's periodic table was that the isotopes could not be explained, such as C12 and C14 are 2 isotopes of carbon. This could not be explained in his periodic table. And another one demerit of Mendeleev's periodic table was that to fit certain elements in his periodic table. So the another demerit of Mendeleev's periodic table was that he arranged cobalt and nickel in wrong order of their atomic masses, such as the atomic mass of cobalt is 58.9 and atomic mass of nickel is 58.7 U. U is the unit of atomic mass that is given by IUPAC, that is International Union for Pure and Applied Chemistry. At that time this organization was not there. So coming back to the point, cobalt and nickel, as we know, the atomic mass of cobalt is more and atomic mass of nickel is less. So he wrote this element first and this element next. So this contradicts his statement that contradicts his statement of that he arranged the elements in the increasing order of the atomic masses. So modern periodic table. This is a modern periodic table. This was made at order out of chaos. That means various attempts did by, as I explained earlier, Daubigny, Newland and Mendeleev tried to classify the elements, but there were some limitations, and this is the modern periodic table. As we can see, it is arranged in proper manner. Like this is a group. The vertical column in the modern periodic table is known as group, and the horizontal column, horizontal row, it is known as period. This group, that is group 1, the elements in this are showing the same chemical properties, such as the valency of hydrogen is 1, and the valency of lithium, sodium, potassium, rubidium, cesium and francium. The valence of all these elements in this group is same. And also the chemical properties, such as when they react with oxygen, they give the same formula. That is oxide and hydride formula. This group, this is a group. This is group 2. The valency of beryllium is 2, magnesium is 2, and so on. When we go down, the valency is 2. When we go, this is a period. This is first period. This is second, third, fourth, fifth, sixth, and seventh. So the elements in one period show the same chemical properties. So the modern periodic table is based on the atomic number. That is, atomic number of hydrogen is 1, helium 2, lithium 3, barium 4, and so on. Boron, carbon, this is carbon, nitrogen, oxygen, fluorine, and neon. And this is the halogen group. That is noble gases: helium, neon, argon, krypton, xenon, radon. These are the heavy elements. So this modern periodic table is the attempt of Niels Bohr and Henry Moseley. So as I said earlier, that the elements in one group and in one period show the same chemical properties. But how is it? Let's see. The hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. This is the first group. So we will take the first trend of modern periodic table. That is what? But what is a trend? If a trend is what, we can predict something according to it. Like the first trend is valency. In the first group, the valence of hydrogen is 1, lithium 1, sodium 1, potassium 1, and so on. The valency of first group is 1. Valency of second group is 2. Valency of third group is 3, 4, 5, 6, 7, and 8. The valency is 8. That means it has no valency. It is a noble gas. Valence electron. The second trend of modern periodic table is valence electron. The atomic number of hydrogen is 1 and the electronic configuration is 1. Of lithium, the atomic number is 3. It is 2, 1. And sodium, the atomic number is 11 and the electronic configuration is 2 and 1. As we can see, the valence electron means the number of electrons present in the outermost shell or orbit of an element is known as valence electron. As we can see, there is only one valence electron in all three elements. That means they are showing the similar chemical properties. This is same applicable to the second group, that is beryllium, magnesium, calcium, strontium, barium, and radium. The third trend of modern periodic table is atomic size. As we go down in the group, atomic size of the elements increases. Like hydrogen has only one shell, lithium has 2, potassium has 3, and sodium has 3, and calcium has 2. The atomic number of calcium is 18 and the electronic configuration is 281. The number of orbits in this element is 4. As we go down in the group of the modern periodic table, in single group, atomic size increases as the number of orbits increases, and the nucleus capacity to hold on the valence electrons is less. So moving next to the next trend of the modern periodic table, that is metallic characters. We'll discuss with first we'll discuss with the groups, and then we'll go the trends of the periods. Metallic characters. What is metallic characters? The elements which show high reactivity are known as metallic characters. High reactivity means losing the electrons fastly, like potassium. Potassium is highly reactive, and sodium is also highly reactive with oxygen, with water, and with hydrogen. Potassium is more reactive than sodium. But why? They are almost they are in single group. They show the same chemical properties. But why we are saying that potassium is more reactive than sodium? It is because potassium has four orbits and its electronic configuration is 281, and sodium's electronic configuration is 281. There are four orbits in potassium and only three orbits in sodium. So the power of nucleus on the last electron is less, and the potassium element loses one electron to attain its stability. And sodium is also reactive, but the third it has only three orbits, and nucleus has more power than sodium's nucleus on its last group. So it also loses one electron to attain stability.
Start.
So we'll see the trends of modern periodic table in periods. So the first trend of modern periodic table in periods is, we'll see valency. The valency of elements in one period. This is the third period. This is the fourth period. We'll see the third period only. The valency of sodium is 1, magnesium is 2, and aluminium is 3, silicon is 4, potassium 3, 2, 1 and 0. As we go from left to right in the modern periodic table, the valency increases from 1 to 4 and then decreases. As we have to the example of period 3, that is sodium has valency 1, magnesium 2, 3, 4 and then 3 to 1. So the next trend of modern periodic table is valence electron. Valence electron also increases as we go from left to right in the modern periodic table. The valence electrons of sodium is 1, magnesium 2, aluminum 3, 4, silicon 4, the phosphorus has 3 valence electrons, 6, and it has 7 valence electrons in its last orbit. The next moving on to next trend in the modern periodic table of periods is chemical reactivity, or we can say metallic character. As we go from left to right in the modern periodic table, the metallic characters or chemical reactivity decreases. As we can see, sodium has only one valence electron and magnesium has 2.
Start.
Metallic characters, as we go from left to right in the modern periodic table,
Start.
as we move left to right in the modern periodic table, the metallic character decreases. As sodium has only one valence electron and magnesium has 2, so sodium takes less time. Metallic character means, or chemical reactivity means, losing electron fastly to attain stability. And as sodium has only one valence electron and magnesium has 2, magnesium takes more time than sodium to release the electron, and this states that magnesium is less reactive than sodium. As we compare aluminum with silicon, aluminum is more reactive than silicon because it has only 3 valence electron and silicon has 4. So aluminum takes less time to lose electrons than silicon. So finally concluding my seminar.
Start.
So finally concluding my seminar, I would like to suggest these classes to JNET aspirants, as this classes is based on the name itself suggests unique foundation classes, that it lays down the foundation for the future JNET aspirants, and it will be easy to crack in their first attempt. So